How's everyone doing today? Is everyone super excited about the new Firebase? That sounds like kind of excited, like, you know, like 9, 10 a.m. excited. Let's get like real. Let's be like, you know, 6 p.m. concert excited. Like everyone, how excited about the real-time? All right, that's a lot better. So I'm here today to talk about two things. And those two things are real-time and offline. And it's kind of funny when you talk about real-time and offline together because they're kind of opposites. Because real-time is a fresh stream of data, and offline is data that we usually get served from a stale cache. So getting them together, it's not that easy. And trust me, I know. I once failed at a startup doing just this. My startup's name was Kale. And we had one mission, and that was to change the world. And we were going to do that by building a collaborative grocery list app. And if it was going to be world-changing, then it needed to be in real time, and it needed to work offline. So when we went to build our app, we started with the backend. And we were like, OK, we need a server. That makes sense. Then we need a database, because we have to store data. So let's do that. And then we had to build a real-time wire protocol just to talk to our devices in real time. But then there's more than one device, so we actually had to talk to multiple devices. So we had to build a synchronizing mechanism so we could talk to all the devices in real time. And then we also had to deal with offline, so we had to build a local cache on each device that could emulate a real-time server so we could serve the changes to the device like it was in real time on the app. And then after that, once the app went offline and went back to online state, we had to send that data back to the server, to the database, and then update all the clients in real time. So like a year later, we realized, oh my God, we haven't even built an app. So we built an Android app, an iOS app, and a web app. And the Chrome team was like, guys, you only need to build a progressive web app. And we're like, I'm sorry, we can't do that. And they're like, why? And we're like, oh, because we ran out of money. So building a real-time offline app, it didn't have to be this hard, because we could have used Firebase. So Firebase is a suite of integrated products designed to help you develop your app, grow your user base, and earn money. And today, I'm here to talk to you about the Firebase Realtime Database. And the Firebase Realtime Database helps you build real-time and offline apps. And the way it works is that every single time one device sends an update to the server, that update is synchronized across all devices within milliseconds. Today, I'm going to cover how you can store data in real time, or store data, and then how to retrieve that data in real time, and then saving data, and then handling offline conditions. So let's start with storing data. So you saw that when I had my little mangly startup, we had this big, complex backend infrastructure. And we were responsible for building this, maintaining it, and hosting it. Well, if we would have used Firebase, we wouldn't have had this problem, because the real-time database is cloud hosted. And what that means is that you don't have to build it, you don't have to maintain it, you don't have to host it. All you have to do is build your app, and the real-time database will do the rest. So how is data stored in this database? Well, it's just a tree of lists and objects. So if you understand what lists are, and objects are, and trees, then you know how to store data. So let's take a little visualization. This right here is the root of a tree. We could create a branch that'll be a list of grocery items. And then in this list, we can have a set of items that all have values that are a grocery list. Now, if you stare at this structure really, really hard, you might notice something familiar. And that's that this is just JSON. And that's because the real-time database is just one big JSON object that you can manage in real time. So if you're familiar with JSON, that's exactly how you store data in the real-time database. And we call this a NoSQL JSON database. So a lot of people who are coming from a SQL background or something and they're not familiar with NoSQL, they always ask me a similar question. How do you structure your app's data? Like, how should I take this JSON data and fit it for my app? And there's just one rule of thumb that you can really follow, and that's you can structure your data after your view. So what this means is that if our data structure is a list of grocery items, and our app is a grocery list app, then we can take these values and we just map them onto the view. And when you have it set up like this, it makes it really easy to read your data in real time. So let's see how we can use the Realtime Database to synchronize our data across multiple devices. So this is the way we did our backend with Kale. It was not really great. We never really mastered real time. So what we would do is we would send a request to our backend, and then we would get a response, and then we could render an item. And while that was just great for one device, the other device has no idea anything has happened at all, because we don't have a connection from the database to this device. So it's always left in the dark to any changes. The Realtime Database, though, has a persistent connection to every single device. So when data changes, it knows what devices to send that data to. And we can do this using the Realtime Database SDK. So the SDK works on Android, iOS, and JavaScript. And with this one line of code, you can create a connection to your database. And this is more than just a connection. This database reference class, it gives us a lot of control. These database references are a handle to an object or a list. So when you create a reference to this piece of data, you have control over it, and it allows you to read this data in real time. So the first reference you usually create is called the root reference, because you're pointing at all the data in your database. And likely, you don't want to read all the data in your database because you're a smart person, and you only want to read just a subset. So let's say we want to get the grocery items. Well, to do that, I can create this child reference, and I can pass in the key of my grocery items. And now, I have access just to that list. And using Realtime Events, I can stream this data in real time. So the two types of events I'm going to cover today are value events and child events. So the way value events work is you can attach them to this database reference. And so what you're essentially saying is every single time data changes in this location, send me an update. And we can receive this update through a callback. And this callback is fired with a data snapshot, which is our synchronized data set. And it's really important to understand that we are synchronizing application state. We're not just sending back updates. And to understand what that really means, I set up this little debug station. So at the top, we're just assigning a value event listener to our grocery list. And then below, we're going to be logging the results to this console. So the first log from the database is going to be our list of items. So we can take this list, and we can display it on the view. Now, let's say a user comes in and adds the item of coffee. What do you think is going to happen inside on data change? So you might think that, well, we added an item of coffee, we're going to get that new item back in on data change. But that's not exactly what's going to happen. What's actually going to happen is we're going to get the entire list, including the newly added item. And that's because this is our synchronized application state. It's the true state of our list. And you might think, like, that kind of sounds inefficient, that if I just add an item, I download the entire set. Well, the Realtime Database SDK is a little bit smarter than that. And what it tries to do is it tries to take delta events from the server And so only taking the item that was added and then piecing that together with your local state. So it becomes bandwidth conscious. So value events are a way for you to synchronize the entire value of an object or a list when anything changes. But sometimes you want a bit more control. You may not want to get the entire object or list back, and you might just want to get one thing at a time. So I might want to know when only items are added, or if items have been deleted, so I can display a fancy little animation. And so that's where we can use child events. So child events are similar to value events in the sense that we can attach them to a reference, but they provide us with more than one type of callback. We can tell when things have been added to our list, when the item's value has changed, and we can even tell when something has been removed. So see how this works? I have that same debug screen up. And the very first event that gets fired is the child added event. And this gets fired for every item, one at a time, that's existing in this list. So I'll first see it for each item at a time. So as I go through, we add an item, and then we render it to the view. So this gives us single control, one at a time. And let's say we go and we want to remove an item. So if a user goes and swipes an item off a list, well, this is going to fire off child removed. And what this will do is when this fires off, it fires off on every connected device. So every device knows how to remove this item. So let's say we change one item, and we change from coffee, and we want more coffee. And what that'll do is it'll fire off child changed, and then we, again, get a callback, and we know this is the item that needs to be changed in our list. And so this is a lot of events. And these provide you a lot of control of how you synchronize your data. But sometimes you'll find yourself writing a lot of boilerplate code to get this to work with common components on your platform. So that's why for Android and iOS, we built Firebase UI. And what Firebase UI does is it takes these database references and it pairs them up with a RecyclerView on Android. So you can take this database reference, pass it to our Firebase Recycler Adapter class, and then every single time an event fires off, we will serve that change and bind it to your view holder. So it handles all of the eventing for you. And if you are an iOS developer, it does the same thing with UI table views. Every time something changes, it takes that change and binds it to the UI table view cell. And if you're a web fan, we have integrations with pretty much every major JavaScript framework. So whether that's Angular, Polymer, Ember, or React, we have integrations that work with your style of flow. So that's how you retrieve data in real time. But that's only part of the puzzle, because to trigger real-time events, you have to know how to save data. So how would we add an item to our grocery list? Well, we know that the initial reference points to the entire database, and that if you create a child, it points to just a piece of the database, just the list. Well, we can again go and create another child from that list, and that gives us an object that we can save a value to. So in this case, we're creating a child underneath the list, so a new grocery item, and we're giving it a key of saying it's the second item, and we're giving it a value of coffee. And the way this works is that when one item sends this update to the real-time database, it's going to trigger a real-time event for each connected device, and then we're going to render that device, or render that item onto the view. And this is what your data flow looks like with the real-time database. You save items and trigger real-time events. And so we can keep our entire application state in sync just through this pattern. But sometimes there can be an issue. Let's say the other device goes, and they also add an item using that same key of item_2. Well, that's going to trigger a real-time event, But it's going to delete the item of eggs. It's going to add the item of coffee. And that's because we use the same key name. And what this is called is a collision. So we're colliding by using the same key name. And the Realtime Database SDK has a really simple way of fixing this. So we'll go back and create our grocery list reference. And then rather than creating an explicit child, we're going to call this method called push. And you can think about it like if it was an array, and you're just pushing a new item onto the array. Because what we're doing is we're actually creating a new item onto our list in real time. But this item we create, it has a unique identifier. In this way, when we use this, we know that we will not be colliding with any items that exist in the database. And when you know that you're not going to have collisions, it sets you up to work offline. So when we were building Kale, we had some serious problems with offline. We were a grocery list app, and then people would go to the grocery store, and then turns out grocery stores are known for having pretty bad connections. So they couldn't even use their app in the store. And so when we went to fix this, we ran into an issue by the fact that real-time, or that offline, it really manifests itself in more than one way. So the Realtime Database handles offline in two ways. The first is intermittent offline. And this works for every single platform, so Android, web, and iOS. And this is like if you go into an elevator or a tunnel for a short period of time and your connection drops. Well, the Realtime Database SDK puts a local in-memory cache on your device. So if the connection drops, we can serve these changes through this cache. So it'll work offline just as it did online. But sometimes you might be going offline for a bit longer. And you might be getting on an airplane, going through a hike in the wilderness, or you just might be spending a really long time in the grocery store. And in these cases, you're likely going to turn off your phone, you're likely going to restart the app, and when you do this, it's going to clear that in-memory cache. Well, the Realtime Database has a simple way of fixing this for Android and iOS. And what it allows you to do is just in one line of code, you can enable a persistent cache on your device. And what this does is if the user goes offline and they clear out of the app, their data will still live on the device. But what happens when they go online? And what happens if they were using the app when they went offline and they were writing to the database? Like, what happens then? Well, the device, as we know, stores this data in a persistent cache. And when it goes online, it just sends that data to the Realtime Database, and that merges the changes on the server and then sends a merged update to every device so everyone can get back onto the same page. So that's how you do real-time and offline. But I wanted to talk a bit about security. Because we're writing all our code on the client. So how do we keep everything secure? Well, the Realtime Database comes with a set of security rules, which are a declarative way to say who has access to what pieces of data. And this integrates with Firebase authentication. So you can log in users and then secure data against them. And I'm not going to go too much into detail on this because Jacob Wenger, an hour ago, gave a talk all about Firebase and security. And if you want to see it, you should check out our YouTube channel that we just launched the other day, where all of the I/O videos are going to be on, and also a series of screencasts called Firecast, which is going to teach you everything you need to know to get started with the new Firebase. And also tomorrow, you should check out Zero to App, where 4 of my colleagues are going to get on stage and live code the same app on Android, iOS, and web, integrating the Realtime Database with Firebase Auth and Firebase Storage. So in this talk, we covered storing data, retrieving it in real time, saving data, and handling offline conditions. So now you know how you can use the Realtime Database to build real apps now you know how to use the Realtime Database to build real-time apps with Firebase. And if you build something, I would love to know about it. So you can get started, and then send me a screenshot, send me anything, a gist or whatever of what you built, and I would love to take a look at it. So that is what we have for today, but for more information on Firebase, you can check out our office hours or head over to our Firebase tents, and we'd love to answer your questions. And just know that when you build with the Realtime Database is that you're getting the best of both worlds, of both real-time and offline. Thank you guys very much.